Today we will discuss about the Leibniz theorem. We use the Leibniz theorem for finding the nth derivative of product function. So we remember this thing also. We use the Leibniz theorem for finding the nth derivative of product function. अगर फंक्शन सिंगल फंक्शन है तो वी यूज द nth derivative formulas. So we write down the statement of Leibniz theorem. Let u comma v be the function of x and the nth derivative dnu into v is equal to nc0 dnu into v plus nc1 dn minus 1 u into dv plus nc2 dn minus 2 u into d square v plus nc3 dn minus 3 u into dqv plus the term is ncr dn minus r into u into d raised to the power r into v plus and so on, or plus the last term will be ncn u into d raised to the power n into v. So this is the statement of Leibniz theorem. So we see that the derivative power of every term is n. Here is dn minus 1 into power of d is 1, so d raised to the power n. Okay, so nc0, nc1, nc2, so this is the combination. So ncr, so we remember the formula of ncr, so factorial n upon factorial r into n minus r factorial. So we remember this formula also. Now we do the proof of Leibniz theorem. So basically when we do the questions, so before doing the question we understand what is the proof of the particular theorem. So for proving this, so basically we use the mathematical induction to prove this. So we use mathematical induction for proving this theorem. So you know the mathematical induction. Mathematical induction say that any value is true for r equal to 1, r equal to 2. So we can assume that this is true for r equal to n. So we shall prove that this is also true for r equal to n plus 1. So same thing we have used here. So means we start with the basic induction. Basic induction means we do the first derivative. So we do the first derivative d of u into v. Capital D stand for d upon dx. So derivative with respect to x, because we write in the statement u and v be the function of x. So d u into v. So we write down the derivative of. So first we differentiate the first function du into, we write down the second function as same. So when we use the product rule for differentiation. So for differentiation of first into second is same, plus first function is same and differentiation of second. So this is our first derivative. Now we move to the second derivative. So we obtain the second derivative d square u into v. So you can write down the d into derivative of u into v. So we write down this as derivative of u into v. So we already differentiate in first step. So that means d of u we have already calculated. So we write down this as d u into v plus u into dv. Now we differentiate this. So when we differentiate this, so first function we differentiate du with respect to d. So this gives us d square u into second function same plus first function du same into differentiation of v. So we write down as dv plus differentiation of first du into write down the second dv plus first function and differentiation of second function. So dv differentiation of dv is d square v. We write down this as d square u into v plus du dv. So this can be written 2 du into dv plus u into d square v. So this is the second derivative. Now the second derivative we write down in this form. So the coefficient we move to the first step. The coefficient of du into v is 1. So here is the coefficient is 1. The coefficient of u into dv is also 1. This coefficient when we write down in the form of NCR. So you can write down this as 1C0. 1C0 du into v. So 1 can be written as 1C0 or this one can be written as 1C1 u into dv. So here is the power of d is 1. So as the power of 1, so we see that here is 1C0 and 1C1. So remember this thing. Now we move to the second derivative. So we see that the first term d square when we obtaining the second derivative. So here we have d square or here also d square into uv 2 du dv and plus u into d square v. So this coefficient again we write down as 2c0. This can be written as 2c0 and this two can be written as 2c1. So this can be written as 2c1. This can be written as 2c1. So this equal to 2c0 d square u into v plus 2c1 du into dv plus the coefficient of u is we can take as 1. So this can be written as 2c2 u into d square v. So by using mathematical induction, so this is true for 1, this is true for 2, this is true for 2. So 2c1, 2c2. Okay, so this is true for 2. So when this theorem is true for, so we write down this theorem is true for n equal to 1 and n equal to 2. So this is true for n equal to 1 and equal to 2. So we can write down as this theorem will true for n equal to m. So now we assume that this theorem will true for n is equal to m. So n equal to m. So now we write down the dmu into v, mth derivative, dmuv. So just you write down this step, you can remember the statement. So on the basis of that, you can write down the statement. So we write down this as mc0 dmu into v plus mc1 dm minus 1 u into dv plus mc2 d m minus 2 u into d square v plus mc3 dm minus 3 u into dqv plus and so on plus mcr dm minus r into u into dr raised to the power v plus and so on, or last term will be mcm u into d raised to the power m into v. So this is true for n equal to m. Now we shall prove this will true for m plus 1. So n is equal to m plus 1. So n equal to m plus 1. So we differentiate above equation both sides with respect to x. So we have already the derivative raised to power m. One we differentiate one time the above equation. So we write down the left hand side of this is d raised to the power m plus 1 u into v. Now, so here we have two terms d raised to the power m into u into v. So when we differentiate the first term, the mc0 work as a constant, and a differentiation of first term you write down as m टाइम डेरिवेटिव है इसका, एक बार और डिफरेंशिएशन करना है, तो ये हो जाएगा m plus 1 u into v plus, so we mc0 we treat as a constant, so taken common, plus dmu we write as it is, and differentiation of v is dv. So this is our first term, plus for second term mc1 we taken as common, तो डेरिवेटिव ऑफ दिस टर्म m माइनस 1 पावर है, एक बार और डिफरेंशिएशन करेंगे तो डेरिवेटिव की पावर क्या होगी, इंक्रीज होगी, तो पावर इंक्रीज होगी तो m माइनस 1 प्लस 1, तो डी रेज टू द पावर m हो जाएगी, डी रेज पावर m इंटू यू इंटू डी वी प्लस राइट द फर्स्ट टर्म एज इट इज डी रेज टू द पावर m माइनस 1 इंटू यू, और डिफरेंशिएशन ऑफ सेकेंड gives us d square into v. So this is our second term, plus mc2. Now this is our first term, so we differentiate this, the power m minus 1 into u, and d square we write as it is, or plus d raised to the power m minus 2 into u, and differentiation of this is dqv. We do the derivative. Now when we differentiate this term, so we get mcr we take as common, so the derivative of this t raised to the power m minus r plus 1 into u into dr raised to the power v plus d raised to the power m minus r into u, or d raised to the power r plus 1 into v plus and so on, plus last term will be mcm, the derivative of u we write down as du into d raised to the power m into v same, or plus u into d raised to the power m plus 1 into v. Now we see that the common terms. So first term we write down as d raised to the power m plus 1 u into v. This term is not common, so we write down this term as first term. So d raised to the power m plus 1 u into v, plus we see that the second term means this term d raised to the power m u into dv. D raised to the power m u into dv is common, so we take this term as a common. So we write down d raised to the power m into u into dv, we take as common. So the coefficient of this is mc0. Coefficient of this is mc0, plus the coefficient of second term is mc1, plus now we move to the next term. So this term means this term d raised to the power m minus 1 u into d square v, and d raised to the power m minus 1 u into d square v. So we taken as common. So this term we taken as common. D raised to the power m minus 1 u into d square v we taken as common. So the coefficient of first term is mc1. Coefficient of first term is mc1, or coefficient of second term is mc2. We write down one more term. So next term, this term will be common. So this term will be common, d raised to the power m minus 2 u into dqv, and the coefficient of this is mc2, or next coefficient will be mc3. So we have a pattern, so you can write down the general terms also. So when we write down the general terms, so that means when we take this term as a common, plus d raised to the power m minus r into u, and d raised to the power r plus 1 into v. So the coefficient of this is mcr plus mcr plus 1, and plus, and so on. We write down the last term is, so last term will be this term mcm u into d raised to the power m plus 1 into v. So first term and last term, okay, will be the separate terms. Now we see the pattern of first derivative, second derivative, we use the induction, and the same when we write for n equal to m, and when we do the m plus 1th derivative, so the patterns remain same. Now we simplify these terms. So when we simplify these terms, that means mc0 plus mc1, mc1 plus mc2, mc2 plus mc3. So what is the value of these terms? So we write down this mc0 d raised to the power m plus 1 u into v, plus mc0 plus mc1. So this gives us m plus 1 c1, m plus 1 c1. So m plus 1 c1, and coefficient of this is d raised to the power m into u into dv, plus mc1 plus mc2. So this term will be m plus 1 c2, or d raised to the power m minus 1 u into d square v. Third term mc2 plus mc3. So this can be written as m plus 1 c3, d raised to the power m minus 2 u into d square v, or plus the last term. The last term will be m plus 1 c m plus 1 into u d raised to the power m plus 1 into V. So first term MC0 you can write down as M plus 1 C0. Okay, the value should be 1. And so MCM you can write down as M plus 1 CM plus 1. Okay, so you can write down this as M plus 1 C naught. So we see the pattern. So then we have the M plus 1th derivative. So this term is M plus 1, M plus 1, and D raised to power M into U into dV. So this is true for, we write down that. So here we write down D M plus 1 U into V. So it is true for, this is true for N is equal to M plus 1. So hence this will true for higher term also. So now we put M plus 1 is equal to N. So then the Leibniz theorem, we write down as, we replace M plus N by N. So this gives us D N U into V is equal to N C0 D N U into V plus N C1 D M minus N minus 1, sorry, D N minus 1 dn minus 1 u into dv plus nc2 dn minus 2 u into d square v plus ncr d n minus r u into u dr raised to the power v plus ncn u into d raised to the power n into v. So this is our Leibniz theorem. I hope you understand this Leibniz theorem, and how to apply in the questions we will discuss into the next class.